Alright, okay, so today we are going to talk about mm, what is the derivative of e to the power of x? Alright, well, I think it is clear that the derivative of e to the power of x is itself, which is e to the power of x. But why is it so? Why is it the derivative of e to the power of x is equals to the e to the power of x? That is, if f of x is e of x, then f prime x would also equals to e of x. Why is it so? So there's actually quite a good explanation where you could draw from the first principle of taking the derivative. So we all know that the first principle of derivative, it states that if you want to take the derivative, let's say y, okay, we try to find the derivative of a to the power of x. Let's say a to the power of x. That's a exponential function. A to the power of x. So we know that to take the derivative, we have to use the first principle, which is, we know that the y prime, it is equals to the limit of x approaching 0, for, right, so we continue. It says it is not the x, it should be the h, a to the power of x plus h, where the h is in the power, minus by a to the power of x over h. So this is y prime. This is the derivative of an exponential function. So because we know that the limit is actually an operator, so the limit is an operator, so of course we can factor things out. So if you factor things out, if you factor a to the power of x out, you factor out a to the power of x is equals to the limit, sorry, not equals, a to the power of x times the limit h approaches 0 for a to the power of h, because a to the power of x plus h is a to the power of x times a to the power of h. So a to the power of h minus 1 over h. So here's the fun part. So if you try to take, let's say a is equals to 2. Let's say a is equals to 2. So you can try to take a is equals to 2. Let's say a is equals to 2. So you would get 2x, the derivative would be 2x, because we know ax, it would be 2x for the limit of h approaches 0 of 2h minus 1 over h. So you can try to take this limit. It's very easy. You just take the left limit and the right limit, and you see that it approaches a number, which is this number right here. It would be 0.693. So if you are really sensitive in number, you would already notice what is this number, but I'll keep it a secret. But we try to take for 3. So for 3x, the limit of h to the power of 0, and then for 3h minus 1 over h. So if you try to take this limit, you are going to get, so if you try to take this limit, you are going to get around 1.099. So this sparks the idea. So if you see this thing is 0.693, this thing is 1.099. So by means that there must be a number in between these two numbers where the limit of this thing right here, this thing, would there be a number that this limit approaches 1? That is, the derivative of that number would be that number itself. And that sparks the idea that there is actually a number that its limit, for this limit, it is 1. And that is the number e, the Euler number. There's e. So there is that e to the power of x, the derivative would be e to the power of x, because we all know. Why is it to the power of x? Because if you put e to the power of h minus 1 over h, you take this limit as the limit of h approaches 0 you are going to get 1. And this is actually ln of e. If you don't believe, you can type it in your calculator. You can try ln of 2 would be this number, and ln of 3 would be this number. So this is actually one of the definition of ln. Oh, the natural log is the natural log of x is actually the limit of h approaches 0 for x to the power of h minus 1 over h. This is what you are doing when you are taking the natural logarithm of one number, is you are actually putting it into this operator right here. So that's actually how you find this thing, that is y, and that is the only reason why the derivative of e to the power of x is e to the power of x. Alright, so from this we can get another derivative, which is another popular derivative is you would have, oh, actually, let's write down the, so if you have a exponential function, let's say a to the power of x, and then you take the derivative would be a to the power of x ln a. So this is the general form if you want to take the derivative of a exponential function. So what if you want to take the derivative of a logarithmic function? A logarithmic, let's say log to the power of a of x. It's quite hard, but it's not hard if you can transform into this form, because we know that for sure, we know that the derivative is this thing. So let's try to transform it. So we know that y equals to the log a of x is equals to a to the power of y, isn't it? So let's take the derivative of x with respect to y. So that would be dx dy would be a to the power of y ln of a. So now, is there a way, and in case you don't know, in case you are wondering, this thing, you can substitute the y back and you would get x. So this thing we change it to x, okay? So because if you have a y, if it's a log a x. So this is x because this 2 will cancel out and then you get x. So this is y, it is x. So it is this. So how can we get dy dx? Because there is one, what we want the change of y with respect to x. We don't want the change of x with respect to y. So what we can do is we can just rotate this. We take the reciprocal of this function, because what you are doing is when you are taking the reciprocal, you are actually doing is you are inverting the x's. Let's say if I have a function of x to the power of x against y, then I know that for a function the change of x to y is dx dy. But what if I want dy dx? Is just rotating the x's. It's just letting this be y, letting this be x. Of course I can do that. Oops, sorry. So back to this, it is just rotating the axis. So if we take the reciprocal of this function, let's just dy dx is equals to 1 over x 1 over ln a, and this we commonly won't write as 1 over ln a, we would write as the log of a to the power of e. Okay, not log of a to the power of e, it's log ae, log ae. The base is a. So that is the reason why if you take the derivative of ln x, you would get 1 over x, because the derivative of ln x is 1 over x. Because if you have ln x, you put 1 over x, and then the log a, the ln is log e, in case you don't know. So the log a is log e. So this is 1, so this would cancel out, so you would get 1 over x. Alright, so I hope this helps. This is why. This is the main reason why the derivative of e to the power of x is e to the power of x, and this is why the derivative of ln x is 1 over x.